Is a hockey puck sliding on completely frictionless horizontal ice a reversible process? I'm going to say yes, it is. There's some assumptions in there that we need to investigate, maybe to see why that might really be true. So one of them is horizontal, right? So if you had a surface that was at an angle, right, and if I had some puck on here, my surface is not very flat, but use your imagination, I'm going to say. If we looked at this in the normal direction of time and somebody had just released it, we'd of course expect it to be moving down the slope. And if we looked at it, then played that in reverse, it would be spontaneously moving back up it. So that obviously wouldn't be reversible. So that horizontal makes it possible, right? So if it really is perfectly horizontal as described, which is hard for me to draw, that at least eliminates the issue of seeing something magically slide uphill when you look at it in reverse. So that's okay, that's eliminated. In reality, could you achieve this? Maybe not, because even if the ice is really, really slick, if the puck is sliding on it, eventually there's going to be enough drag forces that it's going to come to rest. But in this example, it says it's sliding on completely frictionless ice. And I think it's maybe fair, given the way that that's described, that we can as well assume that any other drag forces coming from, say, air drag are not going to be there. Maybe I should have said a hockey puck in a vacuum sliding on completely frictionless horizontal ice. With that added assumption, I think that would make it more clear why it's a reversible process. In that sense, if we looked at the video in one direction, maybe it's sliding to the right, but then when I hit the button to show it to us in reverse, instead of sliding to the right, it would be sliding to the left. And there's nothing wrong with that. Hockey pucks can do that as long as it's, again, not somehow like speeding up uphill. That would look weird, but since it's horizontal, if it's just moving along at a constant inertial speed. Another way of making the argument, since we just said inertial, is it's following the laws of physics, right? Since there's no friction, Newton's first law says this thing will continue to slide in the absence of all friction and drag forces with constant speed. It doesn't say that it has to slide to the right or to the left, so the reverse view makes just as much sense following Newton's laws of motion. So that's maybe getting a little bit more precise about some of the statements here. So let's check out the answer. It says yes, as long as the ice is truly frictionless, right? So in that sense, in reality, if somebody said, are you claiming that in reality this would be a reversible process? No, I'm not. I'm just saying that in our imagination, if we can imagine this being perfectly frictionless ice, that would make it a reversible process. In reality, I would say it's maybe as close or very close to a reversible process, but you could say, does that even mean anything? I'm not sure if I'm ready to answer that. I mean, we're gonna, as we develop this further, we're gonna see that maybe the question of whether a reversible process is really possible in reality is not the most interesting question. So going on with the answer, says if there's friction, the reverse process would involve the puck speeding up by the force of friction. So what that's saying is if there were friction, when you look at the video in reverse, instead of going faster at the beginning and then going slower later on, it would start out slower and then speed up. And of course, that wouldn't really make sense for something to do on a horizontal surface if nothing is pushing it, right? Friction also causes slight warming of the environment, which represents an irreversible change in the environment. So I'm really focusing on the idea of friction versus no friction. It was really no friction, like absolutely no friction, that allows us to make the claim of a reversible process. And from the point of view of the definition we were presented about irreversible changes to the environment, the warming that is caused by friction definitely represents such a change.